Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field. Sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Before we begin, a note from our sponsor. I'm Richard Jacobs, Executive Director of the nonprofit Finding Genius Foundation and host of the Finding Genius Podcast. In late 2016, I was rear-ended at 65 miles an hour by a truck on the highway, which sent me off-road into a ditch. The impact of the collision gave me a concussion and other injuries. At the hospital, a CT scan showed that I had thyroid nodules, which turned out to be cancer. It was then, when I had a biopsy of my neck, that I realized even if I was a millionaire, I wouldn't want a second or a third biopsy due to the pain and the invasiveness of it. And appointments at that time for thyroid experts were 3 to 6 months out. And I was worried about dying now, even if that was irrational. So because of this, I've decided to raise money to conduct a literature review on steroids, on the causes of anxiety and depression, a condition that affects well over 50 million people in the United States and hundreds of millions worldwide. Our goal is to create a codex, a guide that reveals all possible treatments for anxiety and depression for people that live with the condition, or for loved ones that have it, as my wife and my son do. To find out more about our fundraiser, visit findinggeniusfoundation.org and click on current initiatives. And now, to our guest.
Hello, this is Richard Jacobs with the Finding Genius podcast, now part of the Finding Genius Foundation. I have Xavier Fettweis. He's a research associate. He's part of the Department of Geography. Xavier, first of all, thank you for coming. How are you doing today?
Fine.
Okay, very good. Tell me about your current research. It looks like you're studying, the formation and movement of ice sheets. Please let me know about your research.
I'm studying mainly both ice sheets, Greenland and Antarctica, and I'm developing a regional climate model called MAR, this ice sheet. And my research is mainly about the current climate and future. It means that I provide for the IPCC, for example, of both Greenland and Antarctica ice sheets.
Okay, and how are the ice sheets measured? What kind of equipment is used nowadays?
Yes, but clear that for example, in Arctic for Greenland ice sheet, it's probably one of the area over the world where we can see the larger impact. And it's clear that, for example, for Greenland ice, every year the Greenland ice of mass due to global.
Oh, so you see every year what the Greenland and the Antarctic ice sheets are retreating consistently? They're not surging back to their previous levels?
Yes, for both ice sheets, every year there is a mass loss. And no, this last year, we haven't a year with a gain of mass. Every year we have no last.
What do you use to measure the ice sheets? What kind of equipment? Are you measuring the thickness of it, the reflectivity, the outlines of it? What do you measure?
With the satellite, we can measure the amount of water mass, in fact, and we can compare the amount of ice which are above the continent following each year. And with this, we can evaluate if the ice sheet gain or lost mass. Look here. My research is mainly above the surface of the ice sheet. I'm simulating surface and for the surface we can have also some measurement. There are some station, there are some measurement. We can evaluate if at this station we have a gain. And yes, for example, above the model it works very well. My model is able to simulate what we are observed.
Well, again, what is being observed? Is the ice getting thinner? Is it covering less area? Is it, receding? Let me see 1 second. Is it receding evenly, or there's certain parts that are receding more than others?
Yes, but for example, for the Greenland ice sheet, Antarctica is a bit different. But for the Greenland ice sheet, yes, we see a thinning of the ice sheet, in particular along the margin, and we can see also a retreat of a glacier towards inland. It's for the Greenland ice sheet. For Antarctica, it's more complex. So we cannot see a change at the surface of Antarctica because currently the climate is still too cold and no surface melt Antarctica. But what we see in Antarctica is the increase of the speed of glacier, discharge for iceberg in the sea. And we can see also a big collapse for some ice.
Well, as a percentage of all the ice, how much ice is going away each year or not returning?
Yes. For example, for the Greenland ice sheet, it's about 500 gigaton of water every year. And for Antarctica, it's the same.
Okay, the water is not lost. It's just changed from ice and it remains water instead of turning back into ice, right? But
Yeah,
that's how you say it, is it's lost?
Yes, it means that in fact, every year for the recent year, every year, the ice sheet put about 2 millimeters of sea level equivalent in the ocean.
If either the Greenland ice sheet failed to form or the Antarctic one failed to form, what would that mean? Or what do you project going forward over the next, let's say, 50 or 100 years? If the ice sheets keep melting this way, what do you think will happen?
But the problem for the end of this century, the projection is for Greenland ice sheet is sea level projection. For sea level rise contribution of about 20 meters. For Antarctica, it's between 20 and even 1 meter of sea level. There are a lot of more Antarctica. But for example, for the problem for the Greenland ice sheet, if the thinning of Greenland ice sheet is too high, it means that the altitude of the surface of the ice sheet will be a lot of lower than currently. And even if we come back to the next century to a more normal climate, like now, for example, the altitude of the ice sheet could be too low, be able to regrow even in a normal climate. And it is one of the problems, and mainly for the Greenland. And in this case, the melt of the Greenland ice sheet will continue in future, even if our climate is normal, and the contribution of Greenland ice sheet to sea level rise will be 7 meters.
Well, why does it seem like the Greenland ice sheet is melting more than the Antarctic ice sheet? Is that true, or are they melting evenly?
Yes, the problem with the Greenland ice sheet is that already currently the Greenland ice sheet is melting. For Antarctica, the climate is too cold, and we need big warming to start to melt for Antarctica. But the problem of Antarctica is different. It's mainly the ocean, in fact, in Antarctica, because Antarctica ice sheet is directly in contact with ocean, and the ocean is even below the ice sheet because the mass of the ice in Antarctica is very big amount of mass, and the continent of Antarctica is below. So it means that we have the ice sheet in surface, and below the ice sheet we have an ocean which is becoming more and more warm, and therefore it's perhaps the Antarctica ice sheet can melt below the bottom of the ice sheet, and this could induce big instability in the Antarctica ice sheet. So a melt in surface for Antarctica is a melt below the Antarctica warmer ocean.
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now back to the show.
So in Antarctica, is it just like a gigantic piece of ice floating, or is there land underneath it, or is there ocean underneath it?
Ice is on the continent. Look, it's not floating ice, but below, between the ice and the continent, there are in some area there are ocean and warm water.
Oh, really? So like a sandwich between the ice and the underlying earth, the underlying continent. You said there's some ocean intrusion.
Is that what it looks like? I mean, like, so
in use a big crevasse and so on, and big instability.
why would there be warmer water in there? Does it get trapped? Does it come in from the ocean and circulate under the ice, or are there discrete pockets that aren't open to the ocean that are isolated from everything?
No, in fact, the ocean is the water arrive around Antarctica ice sheet come from another area in the Earth. There are currents which bring more and more warm water towards the ice sheet.
You say that there is some warm water underneath
Yes.
the Antarctic ice sheet. What do you mean by warm? What temperatures are we talking about?
Yes,
versus the ice itself and the surrounding air.
It's the freeze it's close to 0 degree, but it's enough. Currently it's 1 or 2 degree Celsius degree, but it's clear that at the end of this century we should have warmer water, 5 degrees for example, and it's clear that it's enough to melt everything. Currently, before the era, the oceanic water was below 0 degree in fact, because in the freezing point of ocean is minus, and therefore it was enough liquid water, but no melt of the ice. No is above.
So how does these pockets form? Have you been able to model that? Where do they come from? The water underneath the ice.
I'm not a specialist of ocean, but for example, in my model, I'm simulating only the sphere. But I think most of the water comes from the tropical area.
So you think it intrudes underneath the ice in Antarctica? The currents bring certain warmer water down there, and it enters in underneath the ice and stays there and starts to melt it.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
Yes. This could destabilize the ice of the glacier.
Well, has that been observed that the ice has been destabilized, or does the water under there, under high pressure, I would think there would be tremendous pressure underneath the ice if there is water there between the ice and the earth. So that water at super high pressure, like what happens to it? Does it remain liquid even at 0 temperatures, or is the water truly warmer and that's why it's melting everything?
Yes, the temperature can be. The water remains liquid, is clear, and because a larger part of Antarctica is direct in contact with ocean, and another problem for Antarctica is the ice shelf. In this case, it's a floating ice surface of the ocean. This ice shelf play the role of like bouchon of the bottle, and we have a lot of ice and ice shelf, several big ice shelf, and this ice shelf disallow the ice to flow towards the. And if the ice shelf break, in this case, the ice can flow directly a lot of quicker ocean, and this could also induce destabilization of Antarctica. And the ice shelf, which are the flat platform of ice at the surface of ocean, and for the ice shelf, we have a melt above the ice shelf at the surface because the altitude of ice shelf is level, and the ice shelf melt also below the ice shelf. We have a melt above and below, and this induce break of collapse of ice shelf, knowing that ice shelf are like a bouchon of a bottle, and if you open the bouchon, the bottle can.
So in the Arctic, does the underlying mass of Greenland, does it act as a source of heat to consistently melt the ice, or what causes the ice to melt there in particular?
In Arctic, it's more the atmosphere. We have a big warming of atmosphere. For example, in Arctic, the warming rate currently is 1 degree by 10 years. If Greenland and ice in Arctic melts, is mainly because temperatures are now already in summer a lot of higher degree. And for example, even this summer, even at the top of the ice sheet, observed summer rain and then temperature above zero.
Okay, so are you trying to model what will happen to the ice sheets over time? Like, what is your model specifically looking at?
My model simulates what is called the surface mass balance. The the difference of the mass gain by snowfall in winter minus the mass lost by melt, surface melt. And therefore, what we are interested for the ice sheet, which is interesting, is the mass balance, evolution of mass balance. And for simulating the ice sheet, we need a model like me to have what is currently occurring at the surface of the ice sheet. But we need also an ice sheet model which will resolve the dynamics of glacier and so on. And therefore, the result of my model are used to force ice sheet model. And with this, we can have an idea of the total mass evolution.
So what happens when, after the summer, when things melt, it starts to go back into winter? How does the ice sheet reform differently in recent years versus in the past?
Yes. In fact, every year, the ice sheet gain mass in winter and lost mass in summer. And due to the gravity, in fact, we have two areas over in the ice sheet. We have the accumulation area at the top of the ice sheet, where every year the ice sheet gain mass, and we have the ablation area along the margin of the ice sheet, where every year the ice sheet lost mass. And due to the gravity and the ice dynamics, the mass gain in the accumulation area is bring towards the ablation area. If the ice sheet is in equilibrium, the topography of the ice sheet will remain the same. It means that the mass gain in the accumulation zone is equal to the mass loss in. Currently, what we are observed, we don't see an increase of accumulation in the area, but we see a big increase of melt in the ablation area, and therefore a thinning of the ablation area and a retreat.
Is the ice forming in other places, or it only forms in the accumulation area, and it's just not accumulating as much as in years past?
Yes, it is ice only form in the accumulation area. It's the accumulation of snow, and after a couple of years, snow becomes ice. The pressure of the snow above the snow, and it is the ice sheet altitude is 3 kilometers. And it is for this reason that we have an ice sheet there, for example, in the Greenland ice sheet, because we have 3 kilometers of ice. If we remove the ice, even if the current climate, we should not form a new ice sheet. The Greenland ice sheet is a result of the past. Okay?
What does that mean? What does that mean? So if there's existing ice, okay, so in the accumulation area in the Arctic, is there always existing ice there year round, and the accumulation happens on top of existing ice? Or are there areas that have no ice in the summer and it snows enough and accumulates enough to form a sheet?
No, the ice sheet is there because there are 3 kilometers of ice, and it means that the altitude of the top of the ice sheet is an altitude where where most of the precipitation are snowfall, and where we have no melt in summer. If we remove the Greenland ice sheet, and if we over the Greenland continent, even with the current climate, a new ice sheet cannot form. And therefore, the Greenland ice sheet is a result of previous glaciological.
Well, I would guess at the edges of the ice sheet in the Arctic, if the ice is retreating, there are now parts that used to have permanent ice that don't. So the parts that don't have permanent ice anymore, it all melts in the summer. Do those areas tend not to reform with ice in the winter? Only the areas that have existing ice?
Yes, okay, I see. No, in the summer, in fact, it is due if the ice which is lost by melt in summer, it is replaced during the winter by thanks to the glacier dynamic. The glacier bring mass from the top of the ice sheet towards the ice sheet margin. And even if we lost mass every year in the ablation area, due to the glacier, it's enough to maintain ice.
So are the accumulation areas and the ablation areas separate, or they flow into one another? Are they right next to one another?
Yes. But in fact, the accumulation area is 50 or 90% of the ice, and the ablation area is only 10% of ice along the margin. But all over the Greenland, for example, there is a lot of snowfall precipitation, and all of this mass is enough to maintain in the ablation area, while in several areas, we lost every year 10 meters of ice. But the glacier bring mass from the top of the ice towards this area, and even if we lost 10 meters of ice every summer, the ice remains.
Well, so I'm trying to imagine what it looks like. So are the edges really what melts? Is that the ablation area is the edges of the ice, and they're just melting and not reforming as where they were? So the edges are coming in? Is that what the ice sheet looks like? Or what does it look like over time? So the edges are coming in, but you still in the winter have glaciation that tries to reestablish the edges, right?
Yes.
But it doesn't reestablish them as far out, or like what changes every year? What does it look like, the ice sheet? How is it changing? Is it changing shape? Is it just getting smaller radially? Like, how is it changing?
Yes, but clear that due to global warming, we have more melt than before, and therefore, in the edge of ice sheet, but we observe a thinning of the height of the ice, and also for some glacier, some glacier retreat of the glacier because the melt in summer is too high. And even due to the ice dynamic, it's not enough to bring enough new ice in this area, and therefore we observe a retreat peripheral glacier ice sheet of several kilometers.
Okay, but it's on the edges you're seeing okay, so the edges come in and don't reform as much. Is ice reforming in some parts and not in others? Is it uniformly retreating, or is it retreating in some areas and not retreating in others? Or is it advancing in any areas?
No, it's clear that for Greenland ice sheet, it's a retreat every year, everywhere, every area, and all around the ice edge. For Antarctica, there are some places where there is mass gain, but in average, it's a mass. But for Antarctica, as we have no surface melt in summer, it means that with global warming, at the beginning at least, global warming will increase the precipitation over Antarctica. It means that with global warming, Antarctica will gain mass in surface.
Okay. When do you most notice the retreat of the ice? In the summers, is it more apparent, or in the winters, is it more apparent?
I think it is in the summer. And for example, for some glacier, we can see a retreat every summer. We see a retreat. In fact, most of the time, most of the measurements are done at the end of, and we compare each year. We compare the end of.
But do you also look at the winter? How much it waxes and wanes?
Yes, sometimes there are big accumulation, but. Well, we can have big accumulation during winter, but what we observe is that even with the global warming, with the impact of global warming, we observe no significant change of snow. It means that every year and every winter the ice sheet gain the same amount, and therefore what we see the impact of retreat, we can see the impact.
What's the timeline of your projection? What are you seeing happening over the next 10, 20, 50, 100 years?
For example, clear that if we want to melt the whole ice sheet, we need at least 1,000. And but as explained earlier, the problem is to not go above a tipping point. And it's clear that with the worst scenario of CC, such tipping point could be reached before the end of.
What would be reached before the end of the century?
This century, before the end of this century.
What would happen? What will happen before the end of the century, you think?
If the tipping point of the ice sheet is reached, it means that Greenland ice sheet could completely melt, even if we come back to a colder climate.
Okay, so if the whole thing ends up melting, then will nothing reform in terms of ice, or what do you think would happen?
It will be impossible to reform the ice sheet because due to the altitude, if the altitude, the thickness of the ice sheet is too low, the altitude will be lower, and we gain 1 degree by above 100 meters of height. And therefore, for example, the current altitude of the ice sheet is 3 kilometers, and if after several decades of big melt, the thickness of the ice sheet is 2 kilometers, it means that the temperature at the top of the ice sheet, even if we come back to a normal climate, the temperature will be between 5 and 10 degrees warmer than before.
How will the Arctic ice sheet melt affect Antarctica? If it melts completely, let's say, what will happen to Antarctica?
Yes, but in fact, due to the gravity again, the water coming from the Greenland ice sheet go towards the south hemisphere, and the water from Antarctica go towards the north. And if the Greenland ice sheet melt, this will increase the sea level in Antarctica, And as the Antarctica is very sensitive to ocean, it's clear that there is an impact, a huge Greenland ice sheet melt toward Antarctica, because in this case, induce a sea level rise in Antarctica, and therefore an increase of melt by.
All right. So do you think it'll accelerate changes in the Antarctic once the Arctic melts? And do you think will the Arctic melt first, or are they melting together essentially?
Probably the Arctic will melt first, but yes, I think at the beginning it's Arctic, but very quickly it will be also Antarctic.
Okay. So what's next for your modeling? What are you trying to look at this point and figure out? Are you refining the model, or what's your goal at this point?
Yes, for the model, yes, but it's clear that when we are developing a climate model, but we need to improve the model by representing new process, or by improving some process. It is one thing. Another thing is to improve the speed of the model, the computing speed of the model, be able to use several CPU and some development in this. And with my model, I plan also now to couple my model with other models. For example, we can couple my model with an ice sheet model. In this case, in my model, the ice sheet topography is fixed, and if my model is coupled with an ice sheet model, I will be able to take into account the deformation of the ice sheet. We can also couple my model with an ocean model to better represent the interaction between atmosphere and ocean. For example, there are several developments like this. Probably it will be the future of climate model is to have a climate model resolving ice, atmosphere, ocean, everything at the same time. And what I plan also to do is to the resolution of my model. For example, if I want to simulate some ice caps in Arctic, there also.
Okay, well, very good. Xavier, what's the best way for people to find out more about your work? Where can they go?
I think the best is to go to my website.
Okay, would you mind giving the how to find you? Probably people can Google your name, might be the easiest. So it's.
Yes. If we Google my name, we will find my website. And on my website, there are some results of my model. For example, we applied my model also in weather forecast mode over the ice sheet to anticipate the big melt event.
Okay, well, very good. Well, Xavier, thank you so much for coming and talking about your models and all this. It's very interesting. I appreciate it.
Okay, you're welcome.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.